Now I will show you how to find a root of the equation, but before that I will look at real examples of these methods. Now suppose you have $475. In this case, I guess the range is less than $100, you said, no. Again I guess the range is less than $800, you said, yes. Then I said the middle value of this range is $400, that is 0 plus 800 equals 800 divide 2 equals 400, you said, no. Now I have two ranges, the first $0 to $400 and the second $400 to $800. First, I said first range, you said, no. Then I said the second range, you said, yes. Then, I said the middle value of this range is $600, you said, no. Now I have two ranges, the first is $400 to $600 and the second is $600 to $800. At first, I said first range, you said yes. Then I said the middle value of this range, $500, you said, no. Now I have two range, the first $400 to $500 and the second $500 to $600. First, I said the first range, you said, yes. Then I said the middle value of this range is $450, you said, no. Now I have two ranges, the first $400 to $450 and the second $450 to $500. First, I said first range, you said, no. Then I said the second range, you said, yes. Then I said the middle value of this range is $475, you said yes. Here I told the correct value by using the middle value 5 times. It was an example of bisection method. Now, let's start with the bisection method first. Let's suppose a b be in closed interval. You need to check if the root of the equation is in the interval or not. There is a Descartes rule of sign to check it. It says, if a root of an equation lies on a closed interval ab, then the product of functional value of this point is less than equals 0. Now you have to find 2 points as the functional value of one point is positive and other one is negative, then their product will be negative. So there is a root between those 2 points. So you can find it by calculation. But if you ask why the product of functional value is less than equal to 0, then show this. Here they have a root at a point x equals 4 as the curve cut the x-axis at this point. Now forget this. Now a curve contains infinitely many points. Let's suppose the positive functional value occurs on y-axis upwards the x-axis and negative functional value occurs on y-axis below the x-axis. Now take minus 4 and 1 points on x-axis. For this graph the functional value of both this 2 point is negative. So both the value is below the x-axis, then the curve can't cut the x-axis between these 2 points. Again take 8 and 10 points on x-axis, here the functional value is positive for both this point. So both the point is above the x-axis, then the curve can't cut x-axis between these 2 points. Now if you take minus 1 and 8 on x-axis, then functional value of minus 1 is negative and functional value of 8 is positive, so one value is negative and other value is positive, then the curve must cut the x-axis between these 2 points. So if the functional value of a point is positive and other one is negative, then the equation have a root between these 2 points. But while calculating the functional value if it is 0 for such a point, then this point is a root, for this reason there is equal to case. Now go to bisection method. So, if the root contains on closed interval AB, then break into 2 parts on its midpoint, and this is we call as x1. Here we have to check x1 is root or not. That is if the functional value of x1 is equals 0 or not equals 0. So, if it is 0, we stop this process and x1 is a 1 root. If x1 isn't the root, then must it is either on closed interval ax1 or closed interval x1b. Now there is 2 interval ax1 and x1b. We have to check, in this 2 interval where is actually root lies by using Descartes rule of sign. In which interval the root lies, we divide this interval into 2 parts. Again we have to check on midpoint, and continuing this process while this midpoint satisfied the equation. Suppose the root is at red point. Then obviously ax1 satisfied Descartes rule of sign. Then dividing this interval at midpoint check whether it satisfied the equation or not. So divide again, then this is actual root. Now solve yourself.